So in this question, we're told about some function, z of t. It's the product of two other functions, or two other signals. And then we're asked to find the z of 0. Now that is the Fourier transform, so it's z of omega, where omega is 0. So what we would need to do is to write out the definition of a Fourier transform. So z of omega is the integral of z of t times e to the minus I omega t dt. And we would replace z of t with x times y. So x times y, that's x, and that's y. So I will do that by moving that along, making some space, and writing this out. So it's 4 delta t times 7 cosine 91t. So this looks like quite a complex integral. We have an impulse, we have a cosine, and we have an exponential. But remember, whenever you see an impulse function inside an integral, there's a possibility of applying the sifting property or the sampling property of the impulse function. So that sifting property says that we can find the value of t that makes the impulse non-zero, so that will be 0, and then we can substitute that into there and into there, and then that allows us to find the answer without calculating the integration. So the final answer is simply 4 times 7 times cosine 91 times 0 times e to the power 0. So both of these are just 1, so the answer in this case is simply 28. So what looked like a lot of work, we ended up doing in one step simply by realizing that there was a sifting property we could apply. So that's how you would answer a question like that.